Launching rockets into space is a high-risky business. It takes years to build a rocket, requires hundreds of crores as investment, and in the end, a small mistake can turn the big-budget rocket into ashes in a matter of seconds. Overall, it is difficult to survive in space industry. But Indian Space Research Organization or ISRO is defying all these rules. ISRO's missions are inexpensive and has one of the highest success rate in the world. Due to its cost advantage, ISRO has become the favorite destination for the companies around the world for launching their satellites. So far, ISRO launched satellites for 33 countries. And in 2017, ISRO created history by launching 104 satellites in a single launch. Out of them, 101 satellites are from foreign countries. But how does ISRO manages to launch satellites at such a low cost? In case of ISRO, it's just not about the rocket science which makes the rocket launch possible, but also the economics behind it which makes it affordable. So in this episode, we will decode the rocket economics of ISRO.
2, 1, 0, plus 1.
India now has launched 104 satellites on board a single rocket.
Took 300 days, but cost just £45 million.
From a cost standpoint, impressive because it's being done by a government entity.
मार्स ऑर्बिटल मिशन हॉलीवुड फिल्म की औसत कीमत से भी कम में कामयाब हुआ है. The success of our space program is a shining symbol of what we are capable of as a nation.
Before we get into the topic, we have to understand how a rocket works. No, we are not going to talk about the rocket science here. We just have to understand a rocket from the cost point of view. It can be understood with a simple example. Let's take a truck. What all different parts it has? Broadly, an outer structure, engine, and a load which it has to carry to the destination. In the same way, a rocket also has an outer structure, engine, and a fuel tank which makes up for the 90% of the rocket's body. And finally, the payload like satellites, goods, and sometimes people, which weighs around 10% of the rocket's body. Just like our truck, the objective of the rocket is to carry the payload to its destination, which is space. Most of the satellites orbit in an area called low Earth orbit, which ranges from 160 kilometers to 1000 kilometers from the ground. But there is a catch. In our example, our truck returns back after delivering the goods in the destination in the same shape. But in case of rocket, it doesn't work that way. After the rocket launch, there are different stages where one by one each part of the rocket falls back to Earth. And what finally remains in the space is a small payload or a satellite. Most of the time, these fallen pieces of rocket land in sea. And because they fall from hundreds of kilometers of height, they end up in a bad shape and not all the cost spent on making these parts can be recovered. That being said, some of these parts can be recycled. Now you can understand that it is not possible to reuse the rocket. For every space flight, a new rocket needs to be made, unlike our truck which can be used multiple times to deliver the goods. However, companies like SpaceX started using reusable rockets which reduce the cost drastically. As we understood how a rocket works, it is very important to understand why rocket launch is costly. You must have got some clue from our initial explanation that we are trying to launch a small payload which makes up for 10% of the body using a huge rocket which cannot be reused. Also, the process of making rocket is complex. That's where the word rocket science becomes synonymous with complexity. Because we are sending a rocket into space, every part of the rocket has to be made from a best quality metal. To withstand the hostile environment of space, they have to be coated with special chemicals. Every component has to go through a rigorous quality check, months of testing and simulations. The process needs highly skilled engineers. Hundreds of crores go into this process. And after this process, when the rocket is ready, you have to get everything right at the first instance. Because in the business of rocket launching, there is no second chance. If rocket is crashed, all the year's effort and the amount spent goes into vain. The cost cannot be recovered and the space agency's future depends on the success rate. If the missions are continuously failing, governments won't be ready to allocate budget. All these factors make space industry one of the hardest industries to operate due to uncertainty and the huge cost involved. We cannot compare ourselves with NASA, but if you see for the year 2021, India's space budget is 13,949 crores. While in comparison, NASA has a budget of more than 1,70,000 crores. It is clear that we have a limited budget, but ISRO has an edge over other space agencies in terms of manpower. You see, the whole process of rocket development needs highly skilled engineers, and their contribution is critical to the success of the mission. In India, we can get the best of the best engineers at a fraction of the cost. Mainly because engineering is the most popular profession in India and our pay scales are very low compared to US. Take the example of software engineers. As per the report by Hackers Eye in 2020, software developers in US paid almost 3 times more than the Indian counterparts. It helps ISRO to keep the manpower cost within the limits. Another major cost involved in manufacturing a rocket is components. Various spare parts, engines, electrical systems, rocket structures and more. These are also the parts which fall back to Earth and won't be useful, but are crucial in sending satellites into space. One factor which is in favor of ISRO is indigenous manufacturing. Majority of the rockets and satellites of ISRO are developed in India using Indian raw materials and components. ISRO imports very few components from foreign countries, which saves a lot in the form of import duties. Most of the requirements are also outsourced to local manufacturers who provide finished material to ISRO at a price less than their foreign counterparts. For example, the Special Electrical and Electronics Drives Division or SPEED has been supplying different motors to ISRO at a fraction of the cost. Earlier, ISRO was procuring these motors from abroad for an average cost of 40 lakhs per motor. But now, SPEED provides them at half of that price. How did they do it? It is through re-engineering. They import 1 or 2 of these machines from other countries. They try to understand how these engines operate and create the Indian version of it, which then supplied to ISRO at low cost. Also, some of the parts and satellites are manufactured in-house through 2 companies, Antriksh Corporation and New Space India Limited, which are wholly owned by Indian government. An important point we have to understand here is that we don't need a separate space industry to manufacture the components required for a rocket. We already have an aerospace industry in India which caters to defense and aeroplane manufacturers. In terms of operations, aerospace industry is similar to space industry. They can manufacture the components for ISRO. So there is an abundance of suppliers. All ISRO has to do is to call for tenders and give the contract to the lowest bidder who can ensure quality. So the ISRO suppliers list includes Mishra Dhatu Nigam Limited or Midhani, Hindustan Aeronauticals Limited, Bharat Electricals Limited, and you will be surprised to know L&T, Godrej, Tata Advanced Systems and Amar Raja Battery are also the suppliers of ISRO. We often underestimate Indian space industry, but it is a lot bigger. As per 2021 report by Space Tech Analytics, there are 368 Indian companies operating in space tech industry and we are the 5th largest country in terms of number of companies. And you will be surprised to know that the company that is aggressively investing in space tech is Wipro, which invested $1.1 billion in 2020 alone. We must understand that to launch anything into space, weight is the most important factor. It also responsible for the overall cost of the mission. So, ISRO saves cost by sending lightweight satellites into orbit, whereas some NASA satellites are so heavy that they require a powerful rocket to put them onto orbit. Take ISRO's mission till date, we are not launching any super heavy satellites. Even when ISRO created a record by launching 104 satellites into space, 88 of them were weighed 4 kilograms each. ISRO has 5 launch vehicles based on the payload weight. Most frequently used one is PSLV, made to launch lightweight satellite, and ISRO is in the process of building SSLV, which will be used specifically to launch smaller payloads. It is clear that ISRO is trying to target those companies which want to launch small satellites, and it is economical. Even during the Chandrayaan 2 mission, ISRO was able to utilize its limited resources very effectively. In 1969, the Apollo 11 mission, which took US astronauts to the moon, took around 4 days to reach the moon. In comparison, Chandrayaan 2 mission took more than 40 days to reach the moon. NASA had used a very powerful rocket called Saturn V. In the Chandrayaan 2 mission, since the resources were very limited, ISRO used a method called slingshot. It can be compared to train and air journey. Though the destination is same, the latter takes less time due to the power of aircraft. The train journey takes time, but it is economical. After the rocket and satellite are ready, they have to go through a rigorous testing for months, which is time consuming and expensive. So, ISRO conducts very few tests and try to get best out of them. It saves money and time. This may sound dangerous given the odds of successful rocket launch are very low, but ISRO is following this process since their inception. ISRO's track record is pretty good. Till date, out of 82 rocket launches, only 9 missions failed to launch successfully. The final factor which makes ISRO the winner is their mindset. What do I mean by that? We know that the space budgets are very low, so ISRO has to get best out of it. It has to optimally utilize the available resources and build a world-class rocket at lowest possible cost. Over the years, ISRO worked with this mindset. It not only drives innovation but also builds a mindset where every employee is dedicated to achieve the common goal with the limited resources. For example, we all know that if a project is not delivered on time, it increases the cost of the mission. So all the missions have to be on time. Working 18 hours a day is a common practice in ISRO, and during the launch period, many of the scientists work 20 hours a day. Being time effective makes them cost effective. All these factors together help ISRO to be the prize leader. Gone are the days when going to space was only meant to showcase power. Today, space industry is different. We are seeing a growing number of startups entering into this area, and they don't want to send big heavy satellites into space. They want to launch small satellites. They are the potential clients for ISRO. Apart from commercial benefits, we were and still to a large extent are a farming nation. ISRO's capabilities can be used for mapping land, surveying crops and communication in remote areas. ISRO has a huge potential to expand its commercial operations, but the competition is closing in from competitors like SpaceX. How ISRO is going to reinvent itself will define its future. So that's the video, guys. If you feel this video is informative, hit that like button and let me know in the comments what is your opinion on ISRO. Thanks for watching. See you in the next one.